Hello and welcome to episode 5 of our tutorial series, where we'll be making a DirectX ready game engine. In this episode we'll be looking at how we can improve our game engine framework to make it even more streamlined and accessible by our project. We'll be creating the engine class itself and we'll be automating the DLL copying process for us. We'll also be creating a set of core and core minimum files to act as our core dependencies. After this, we'll start to lay out a simulation class which will act as the basis for our 3D world. Before we'll be able to move on to creating our simulation even further, however, we're going to need a window to be able to display it on, and as we'll use this a lot throughout the process, we're going to need to create a dynamic framework to run our Win32 windows from. At the end of this episode, we'll take that Win32 framework and we'll use it to build ourselves a basic splash screen. Now that's a lot of talking and we've got a lot of code to do, so let's get on with it. Before we go charging ahead, I want to just follow a little bit of advice from the last episode. And that's just to make sure that our program is working before we make any changes. So I'm just going to play this, and that shows our mtail is working correctly and we've got everything printing correctly. That's good, it means everything is working and now I can move forward confidently without any doubts that this wasn't working. The next thing I want to do is just fix something that's been really annoying ever since we've started this project. And that's the fact that we need to keep on copying and pasting the DLL over from our engine folder over to our project folder or the build folder for each. We can solve this easily, so if we come to properties for our blank project, we can come to build events, pre-build events, and we'll find the command line. Now this command line will be run when we build our project or before we build our project. Before we move any further, just make sure we're on all configurations to just save any headaches later. I'm going to open this up completely and I'm just going to paste in a new command that I've made for us. This is a copy command, so we can see it's referencing copy, and what this does is it will copy whatever is in this URL and it will place it in this URL. Now the second URL here is easy. This is the build folder for our project. You can see that we're only doing this in blank project, so this will only run when we build our blank project, and that will put it in that folder for us, the build folder. This URL, however, is a carefully mapped URL of our Olympus DLL, and because I've added this part in here as well, it will also correctly map, is this our debug version or is this our release version? That's brilliant. We can click OK, apply, and that should mean now anytime we need to build our project we won't need to copy and paste that across. So let's just have a look into that and let's just hit play and see if this is going to work. Now we're getting an error here and let's have a look and see what this is. There is a problem with our copy command. Now I do know what this is and I've done this on purpose. The problem with this is that our copy command is separated by whitespace characters or by spaces. And we actually have a space in our episode 5 name. You can see that it's here, and this actually means we're cutting our copy command at this point. To fix this, we need to rename our folder to something like E5. There is one small problem with this, however, and that's that you can't do that while the program is open. So I'm going to close this down, rename this folder, and open everything back up. But I'm going to do that off camera, so I'll see you in a moment. Now that we've done all that, I have loaded back up our program after renaming our folder to E5. If I now just play this, we can see everything seems to be working absolutely fine, and this is now because it's automatically copying across our DLL for us. Let's stop that and we can move forward. I want to now look into our engine dependencies. Now, dependencies are the exact header files that will be used to tie everything together in our project or our projects from our engine. At the moment, if we come to our PCH files, we can see that we've got quite a few things in here, and we're calling in the Olympus.h file. Now, this is okay, but really calling in the PCH file of a different project is a little bit bad form. And what we should really have, we should have some common files that we can draw in from both projects. So let's go to our switch views and let's come down. Let's just give that for a moment to weld up. Let's come to folder view and let's come to our new E5 folder. If we come to Olympus, let's come to source, and I want to come into our core file. Now I'm going to add 4 new files into here. I'm going to add core.h, I'm going to add core minimal.h, and this is just so that we can have 2 different ways of adding our engine to our projects. We can have one file which is everything contained in our engine, and we can have another file in which we are only drawing in the specific things that we need to run it on a minimal level. This is how the Unreal Engine does it, and I quite like it. Let's come back to our switch views and let's come back to our E5 solution. We're going to need to draw these in. Now, I've been staring at this code for quite a few weeks trying to get everything ready. And one thing I've noticed very early on is, although we're being very organized, we are also already getting quite cluttered. We have our private folder here and now we have our public folder, and that's given us one level of filter. We also then have common, core and platform, and that's given us another level of filter. As we carry on, this is going to become more and more confusing, and the way this really should be working is we should have our core folder directly in our source, and inside here we should then have our public and our private folders, and that will just mean we can access the specific areas of our game engine a lot quicker when we're working. So let's just do that now. So this is a per game setting, and then we're going to change this to private, and we're going to put our per game settings in here. Unlike just the way we had it before where we had a public and private folder, I actually want to add an extra one in here, and I'm just going to call this classes. Again, I have been going over the code for the Unreal Engine, and this is how they do it. When you find something that you just really like the format of, it's very difficult then to go back. So let's just pass across our per game settings and let's put that in classes. We can now come back and just delete everything from our core files. Core here, and it appears everything's gone there because we copied that across. Let's have a look at what we need to add from our core. Let's come to source and core, and we just need to add all of these in here. Let's start by just dragging our CPP files into our private, and we have our files set up. Now we've done that, we can just start to add in the different things that we would normally put in here. So let's add our pragma once here, and let's do that the same for our core minimal. Now, we're going to focus mainly on what is minimal for running the game engine at the moment. So the only thing we're really going to use our core.h for at the moment is to include our core minimal. And that will just mean whichever one we use will basically do the same thing. To make everything work correctly, we're going to need to put in our include Olympus. But these files are going to go directly into our PCH files. And for that reason, we're not going to put the header files. Let's put that in such. If we come back to our Olympus.h file now, we can see that we're including these settings. And what that means is we can now go in and put that inside our core minimal file. Put that in there as such. And then we can come in here, and instead of including these, we can just add our core. I'm not actually going to use, in our game engine, I'm not going to use the core minimal section, so I'm going to use core. But in comparison, in our actual project itself, just to get us started, instead of putting these in here, I'm actually going to use our core minimal. And this will just show a proof of concept that we can use either one. Now, we're having a lot of different issues here, so let's just have a look to see what that is. I think this is just mainly because we haven't copied and pasted everything across yet. This section here are not dependencies. These are not include files as such. These are actually definitions. And for this, we should have a definitions file. So let's just add an actual new one, a new file in here, and let's just go to folder view, episode file, and let's just add a new one in here called definitions. So core definitions, just call that core definitions.h. Let's add the other file in here as well, just in case we were to ever need it. Don't think we ever will in this case, but it helps us add in our PCH files, so let's just do it anyway. Include Olympus. Again, these are going to go directly in our PCH files, so we don't ever need them again. And really, I can just close this. We probably won't ever need that file again. Let's go back to our solution view, and let's just import this in. So let's go to our core. This is going to go in our public. This is because we're not directly creating a class. This is just generally public files. There may be some confusions later on what denotes as a namespace, what denotes as a class, and what just generally denotes as a public. And again, it's one of those things that really does come down to personal preference. Now we have our core definitions.h. Let's put our pragma once in there, and let's look at what other definitions we need to put across. And in this case, it's going to be most of these, in fact. So let's just grab that and let's put this in here. Our definitions are going to be something that's really going to be needed by our whole program and all of the program for our project as well. So let's not put this back in our olympus.h file. Let's just put an include inside our core minimal. Just say include, turn off caps lock, core definitions. And if we do this, you'll see that our Olympus underscore API DLLs, all of the things that we did there to make our program work correctly is now working. What's the great benefit of this? This means that we really have cleared out our PCH files. We can still use this to add things in like string, etc. But it means we've just designated all of our engine files off to this one new section. And if we come back to our PCH files here, we no longer need this either, because this is now included in our overall settings. It just makes things a lot nicer and easier to manage. The next thing we want to do is just to add in a couple more classes for us to use with our engine. So let's come to our folder view and let's come down to our source. We already have a few filters here. I want to add in a new one, and we're going to call this filter engine. Inside our engine, we're going to add two new classes. We're going to add one class called the O engine, and we're going to add one class called simulation. Let's just add the extra CPP files in there as well. So that's the oengine.cpp and the simulation.cpp. There we go, perfect. Let's go back to our solution view. And as we are now formatting a new way of doing things, let's start in good form and let's just add in our new filter in here. Let's add engine, and inside our engine, let's just add our three new filters. That's public, private, that says pivot, private, and one that says classes. Now in this case, both of these are going to be classes. Our engine is actually going to be both a... I did notice one thing quickly, is that I didn't actually include that class there. So let's just do that quickly, and we can just throw that in our core. I'll figure that one out in a moment. It goes there. Let's just do that and get that done. Let's go back into our engine and go to existing items, so we can come to our engine folder, and let's just import that all in. Our engine and our simulation are both going to be classes. However, they're also both probably going to be namespaces. So this could get a bit confusing. Let's add our CPP files in here. As with everything else we do, we are going to need our standard pragma once. Let's just add that in, and it's gone here and here. And we're going to need to include our Olympus.h. So let's add that in there and that in there. Our simulation file is not going in our PCH file. So let's just add that one in here and add simulation.h header. On the other side, our oengine.cpp or our own engine file is going to go into our core minimal. So let's just add that in now. And that should be engine and oengine. I'm actually going to put that up here before this because it's quite an important file. Now we've done that, we can start working, but I think you can see I've got quite a few files open here. So let's just close all of this down and let's get a little bit more organized. If we can see here, we've now got our common and our platform files. So let's just organize this quickly. We've got platform and we've got common. With the magic of editing, I'm going to add our new classes in here. So I'll see you in a moment. Once that's all done, we are looking a lot cleaner and a lot more sleek. We've got our core files here that we can just open and find everything, and we've now got our new engine files. Now we've done that, we are ready to move on to start building. Let's have a look at our new simulation class. Let's open that up here. Now I've gone ahead and I've created us a quick class just to start from. So let's just put this in here. I'm going to utilize a namespace of Olympus just so that we can identify that this is our simulation. And I'm going to create a class called simulation. Let's just put our basic constructor and deconstructor in here. To make this work, I actually want to inherit this from our iApplication class that we created earlier. That means that we will be able to base our projects directly off of our Olympus simulation class, or anything else that we wanted to create based on our iApplication class, and that's the benefit of doing it this way. To do this, we're going to need to add in a few things. So let's come in here and let's go include platform, Win32 and iApplication. If we now come in here, we can say public and we want to say iApplication. This is now good and this will work fine, but I have a few pet peeves about the way that we're doing this. First of all, when you put things in capitals, it can make it look like it's more of a definition, and I admit fault to this one. It's slightly annoying me that that's all in capitals, so the first thing I want to do is just come down to here and rename this to Win32, but without the capitals. I make a complete apology for that one, that's just my obsessions. That should now work correctly. The other thing that's annoying me slightly about this is when we're dealing with our simulation, we're correctly namespacing it so that we know exactly where it's coming from. But iApplication is very generic and we're not really namespacing this. So if we come into our platform folder here, we can come to, let's go back to the correct solution directory. If we come to our platform folder here, we can come to Win32 and we've got everything laid out already. If we come to our iApplication class, and let's just open our Win33 class as well, we can come in here and have a look at how we're doing this. Now, personally, I think we should be namespacing this as Win32, so let's just do that now. We're going to need to put Win32 in here to make that work correctly. That should all work absolutely fine. If we, however, let's just have a look, see what we're doing in here. Are we needing this any further? We are going to need a namespace around our functions as well. There we go. Now, if we come to our Win33 function, this is going to say it doesn't recognize what's going on, and that's because we now need to put this in here like so. That should make that work. Do we need to reference this any further? No, we don't. That should now be all working fine. Our iApplication has been referenced under our reference of Win32, and we can now upgrade this. That just means it gives us a much better definition of what this is. This is going to be a Win32 meaning inherited application. This is a good start for our simulation, but let's come back up to our blank project. We've got our application class here, and we're currently running off of our iApplication. How about we change this and we run this directly off of our simulation now? So we can go Engine, and we can say Simulation. We can then say we want to run this on Olympus and Simulation. This should now work exactly the same, apart from I think you can appreciate it's a lot easier for us to read. The next thing we can move on to is actually setting up our OEngine class. Now, why are we creating an OEngine class? This is going to be useful for quite a few different reasons. One, it gives us a specific place to store variables. So for example, if we wanted to save the boot time, we could do that in the OEngine. The other reason is it gives us a specific way to access our classes. We can create classes that are static, which means you can only create one of them, which means they can be accessed from anywhere. But sometimes you want to create a class that's not necessarily static, but you do want to reference an individual one of them, for example our simulation. And that's for that reason it's a good place to have all of this kept. For this episode mainly, we are going to use this OEngine class to control and store how we want our simulation to load up. There are quite a few different ways that we could load our simulation up, and we've already got two of these set up in the form of the debug and the release mode. But I want to add in a couple of extra ones for us to think about. I have just created a namespace here with the namespace of engine, and I've created an enum of the type int, and it's called engine mode. We have put none in there just to default. We've got our two debug and release, and then we've got two extras in here. When we're building a game, we are going to need an editor. It's manageable to be able to write everything in code, but as we get slightly more advanced, we're going to be able to want to see and manipulate variables directly in front of us. So having an editor mode on our simulation will be very beneficial. We also want to be ready to be able to run this without any graphics, to just operate as our server. So having this as a server mode available will also be very beneficial. Now we've got those in there, we can now use that to try and figure out how we're going to run our engine. The first thing I'm going to do is I'm just going to add a variable of engine mode to our OEngine. To make this work correctly, I'm just going to add the using namespace engine code in here. It just means I don't have to keep on typing engine mode every time. This will be beneficial later on, and it's good to namespace, so there is a reason for doing it. We can now then use this variable here to track how our engine or our simulation is running. But we need to find a way to actually declare this variable. We need a way to keep track of that. So let's add an external variable, and we're going to call this, it's going to be of type OEngine, which is going to be here. And just to make sure that we can actually access that, I'm going to add a class declaration above the engine. It's a little confusing, I know. We need to add this one above this one, and we need to add this one above this one. But it does work, and it will work. We've now created a new variable here. I've called it external, so we can just declare it once in the CPP file, and we won't need to declare that again. It's of type OEngine, and I've just called this G, meaning global, Olympus engine. This specific variable doesn't actually belong to any specific class, so we'll just be able to use it anywhere in the engine now. And when the actual engine itself loads up, or when the program itself loads up, this variable will be automatically created and ready for us at the beginning. Now, because I made this external, we do need to declare it in our OEngine file. So let's just do that now. I'm just going to put our namespace in there, and I'm going to put that in our CPP file. To make this operate correctly, we're going to need to figure out exactly what mode we want to run our code in. This is not too difficult to do on the first two modes. Visual Studio in general already gives us a definition to know if we're in debug mode, so we can use that just to filter very simply between debug mode and release mode. So if we are under debug mode and we're declaring that, we'll load the engine mode in debug. And if we're not in that, which is grayed out at the moment because we're obviously not, but we could just change this to release, it will then go to release mode. This will be beneficial for showing extra information, for example, in debug mode. That's great, and that's covered off the first two of our variables. We are using the M-engine mode inside the O-engine, and at the very beginning of our program, we are creating our O-engine. So all we need to do now is know exactly which this variable is set to, and we know what the whole program is set to. Let's come back to our O-engine quickly. Now, we have 4 different states here, including our editor and our server, and there's no magical special way for the Visual Studio to show us what this is. So we're going to need to find a new way to be able to feed in information at runtime to tell us if we want to load up as a server or as an editor. And to do this, we're going to do it with command line arguments. As we're now going to be using command line arguments, that means we're going to need a new file for our command line arguments. So let's come back to folder view. This time, we're going to add this into our common file. Command line variables are extremely common and lots of programs use them, so it's a good place to store this. I'm just going to abbreviate this slightly just so that it makes it look a little bit nicer, and we're going to add this in as such. Let's go back to our solution view, and let's come down to our Olympus. Let's close some of these down so that we can really take the benefit of cleaning this all up. Our command line arguments are going to be a namespace. We're not going to make an actual class for this, so let's come down to common. Let's just add all that in there. If you already have the files selected, it doesn't actually add them in again, so this is why I just select all of the files in the folder and just drag them in. Our command line arguments are going to need our usual things, our Olympus. Command line arguments are not going to be used in our PCH file, so let's add their own header in as well, and then we can just add in our pragma ones. There we go, that's a good start. for our command line arguments, we're going to need a new namespace. So let's just put a new namespace in there, and let's say command line args, just the same as we did for the file name. Now we want to create specific functions to be able to read our variables from our command line. So we're going to create a new function. We're going to call this void. We need to specifically put our Olympus API call on this function. Because it's not inside a class, which would normally give it the API call, we need to do it individually on the function. And I'm just going to call this read arguments. If we just quickly create that in our command arguments.cpp, then we are ready to start building this function. Before we do this, however, let's think about where we're going to add this. So if we come up to our win entry, we need to think about where are we going to add a read-in for our command line arguments. We can actually do that here. Before we start initializing everything and creating our logger, we could add in our command line arguments. So let's come up here and let's go include common and command line arguments. We can then go command line arguments and read arguments. This will mean before we've started initializing anything, we can get out of the way what way we want to load the program in. We can then come back to here and we can start working on this function. To do this, we are going to need to get rid of this version of the Olympus API. For some reason, Visual Studio always puts that in, but it's actually not going to work if you keep it. To get our command line arguments, what we're going to need to do is we're going to need to fill out this script. This just says that we are going to use a long pointer to a W string to store all of our different types of arguments. The argc is going to be the length or the amount of arguments we found, and this command here is just going to draw it all in. Now, up to this stage, I've talked very importantly about command line arguments, but I've not really actually explained what they are or how we use them. So let's come up to our blank project. If we go to properties, this time if we go all the way to the top and we come up to debugging, we have this command arguments here. If we, for example, were to put in different variables here, let's put in here mtail, and let's put in here editor. This means that I'm going to feed in a new command in a moment to say only if we've got this -mtail command do we actually load up our mtail, and only if we've got this editor command do we actually load up our editor. And this is how we add these in. Later, when we're actually building the projects in more foundation or a solid state, and we're creating the actual exe files that let us run our program, there is different ways to add these command line arguments. So we can do this outside of Visual Studio as well. It will be greatly beneficial. Let's just apply that off and click OK. What we then want to do, now we've collected all of our command line arguments, is just to loop through them and just check them for what they say. So this is our for loop, and this for loop will go all the way through our command line arguments. Normally with one of these types of for loops you would start at 0, however the first command line argument is always the URL of the build directory of the exe. So I've just skipped that one and I've started us at 1. To identify if this is a correct command line argument or not, we'll have to find out, does it have that hyphen or that line before it? We can actually do that by just taking the very first letter of the command line argument, and we can do that with this command. We're just going to create a W string called key, and we're just going to take the very first letter. More to the point, this doesn't take the very first letter, this takes the very first string, or the string that we're talking about, the specific command line that we are talking about. This command here checks to see if it is a hyphen or not. So let me go back over that again. We're going to create a key. We're going to take the first or the I variable of the command line argument, and then we're going to check to see if that command line argument, the 0th character, equals this hyphen symbol. If it does, then we can start doing some more things. We then want to really say, does this, for example, equals mtail? But we don't want to have to keep adding this hyphen into all of our checks. So it's probably handy if we just erase that quickly before we do anything first. If we were to now understand what this was, and our original variable was /mtail, we are now going to recognize mtail. Just mtail, sorry, no hyphen, because we've just erased it. There are many different ways that you could write mtail, however, with a capital L or capital M or capital T. So let's just run a little command here and let's just bring this all into lowercase. Okay, so this command here will bring this into lowercase, and to do this we're going to need to include the algorithm header. At this stage, our mtail would be reading roughly mtail, so we've got it down to the lowest and simplest basic argument. Now this function is already getting quite long, so what I'd like to now do is create a second function just to read the individual arguments so that we don't have to make this section too long. What I'd like to be able to do is just create an argument that says just read an individual argument and be able to just pass that key straight in. In general, this is a W string, and as you may have noticed, we're not really working in W string, so I have converted that back to the W character array that it's meant to be. If we now go back to our .h file, we can add our new function in. It's another void function. It's pretty much the same as the previous one, but I've given us the ability to add in a constant W character argument. This has to be constant to be able to use some of the functions that we're going to use. Again, we'll need to take this Olympus API call here, otherwise the program won't actually compile. Now that we've done that, we can start to fill this out. So let's have a look. All we actually then need to do is just figure out if we are calling mtail or not. So let's just have a look at this. And we can say if we are recognizing that mtail is the argument that we're being called, the argument is being string compared with this argument and it matches mtail, so basically it equals zeros, it has found a match, then we can use our logger start mtail. Now if we come back and we look at our logger, we can remember that that was the command that we were using to load our mtail with. I think actually if we come back we might find that in our win entry. I'm not actually sure where we kept that, so let's just join a Control F and let's just say, let's just run mtail. What did we call this? This is start mtail. Let's just do it from here. Start mtail. And where did we locate this? Apparently at this is just command. Let's have a go. Entire solution, and let's just run that again. We're actually keeping this in our application class. Here we go. We did this in our Olympus engine. So let's just get rid of that quickly. And now, if we to run this program again, this should all work absolutely fine. And you may notice I have not copied and pasted the DLL over here at all. I also haven't ran this program in quite a while, so we just need to make sure it's working. Now I already have mtail open, so that does not confirm whether that's working or not. Let's just run that again quickly. And mtail is loading. Now that's amazing. Let's have a look at this. Let's have a look at our blank project here and let's go to properties. If we go back to debugging, let's have a look to see what happens if we now take this out. Let's have a look. Let's close out MTAL, otherwise it won't open up. And let's just run that program again. I can confirm that MTAL is not loading up now at all, which means our command line arguments are working brilliantly. Let's just pop that back in there. Okay. Let's go back into our command line arguments and let's have a look to see what else we can do with this. We might want it so that even if we're running in our release mode, later on once we publish the game, we might want to be able to still run it in debug mode so that we as editors and developers can see what's going wrong with it or debug it at the time. So let's add in all three of these different functions. We're saying if we can find a debug, we want to set the engine mode to debug. If we are finding editor, editor, and if we are finding server, server. You can see here that I'm actually using a setter for this, which we haven't yet built. So if we go back to our O engine, I can just give you a couple of these getters and setters, which will just make our life a little bit easier. Let's just copy and paste those in there. We have three different functions here. We have a set mode, a get mode, and I've also added in another little function which is going to be called engine mode to string. That's just so that we can print that out in our logger later. Just going to give us and copy these in. This is going to be set mode, get mode, and engine mode to string. These are pretty basic functions and I didn't want to go through all of the huffle and puffle of actually adding these in and typing them at the time, so I have made these ahead of time. Now to make these utilize correctly, I've also done a very similar thing inside our O engine itself, and I've created getters and setters for that as well, so I'm just going to again add those in. If you want to copy and paste these, they will be available on the GitHub. This is more for learning instead of copying word for word. Let's just add those last two functions in there as well. And once again, this is get engine mode. It's just going to return whatever is going on with our engine mode in here, inside our O engine specifically. And this one is going to set the O engine mode inside our O engine specifically. These functions up here are going to be from our namespace. They are going to be generally accessible, and they are going to get our global engine mode, and they are going to set our global engine mode. Once we see this in working, it will make a lot more sense for anyone who is not currently following. To show how this is going to work, what we can do is we can come into our application file and we can add a new one of these print log declarations. This just means that when the engine is loading up itself, we're now going to print out which engine mode we're using. Now we do have a red squiggly line, which means we've got an error mode here, and the reason for this, I believe, is that if we go into our PCH files, now you may notice a moment ago I accidentally deleted these PCH files and I've put them back. So if we go into Olympus.h file, we can just come in here and hit include string, because we're not actually declaring that globally currently. If we do that, we can also come up to our PCH file here and just make sure we're doing that under Windows.h as well. Save that off and save that off. If we now come back to our application.cpp, you'll be able to see that the red underline has gone and this seems to be working. So we should now be able to test this, and we left this on editor, so now when this loads up we should get a new message saying that we are in editor mode. And now we have fully loaded up, we can see that this is saying debug mode. Now let's check quickly why this is. Let's come into our blank project and let's see what is set up in our debugging. Now at the moment this is set to debug mode. We can actually add in editor in there, so I may have done that off screen. So let's run this again now that we've changed this to editor mode. Again, when MTAL is open, so let's just run this again with MTAL not open. And you can see that we're now successfully loading this in editor mode, which is brilliant, and it gives us in a good stead to move forward with. Up to this stage, we've been working mainly on a theoretical level. We have been adding lots of different classes in that can tell us our engine exactly how we want it to run, and we've given it a great methodology to do so. But we are still lacking one main element of our engine, and that's the fact that we really can't see anything yet. To be able to get a system for being able to load up windows and simulations and everything that we need for our game engine, we need to be able to have a system for being able to load up a basic window. We're using the Win32 API, so we're going to need to be able to build up that window in the Win32 API. Now there's a little trick with Win32 API, and that is that everything is a window. So whether that's a button, a drop down menu, or even our simulation window itself, it's all going to be a window. We're going to create ourselves a basic splash screen, which is also going to be a window. This is so that we can basically create our Windows class and create a basic window to get us started. And then in the next episode we can continue to develop this theory further. With that all said, let's go on and let's create ourselves a splash screen file to work from. So let's come down to our engine and let's come to add new file splash screen.h, and let's add in splash screen.cpp. Perfect. Let's come back up to our solution view. Let's come down to our engine and let's just add those two new classes in. Our splashscreen.cpp is going to stay in our private file here. However, we need to change our splashscreen.h. I am actually going to make a class for our splash screen, but I'm not going to call it splash screen. I'm going to call it splash window. And our splash screen is actually going to be the namespace that we're going to use. So instead of putting splash screen in our classes, I'm actually going to choose to put this in namespaces. And this will come a little bit more obvious later when I show you how we're going to use it. In our splash screen classes, we're obviously going to need to add in our dependencies. So let's add in our Olympus file. And this one isn't going in our PCH file, so we will need to add its own header in here as well. To get us started with our namespace for our splash screen, I have just created this. This is just three basic functions that I want us to be able to use with our splash screen. I want to be able to open it, I want to be able to close it, and I want to be able to add messages to it so we can keep track of what is going on. This is a good time to explain why exactly we use a splash screen and what it's for. When we're loading up an engine and we're loading up a DirectX window and lots of objects and lots of dependencies, loading up that window or that simulation itself can take quite a long time, or it depends on how difficult your program is. We throw a splash screen up on the window just to say to the user, hey, we know that you've requested for this simulation to load up. We're doing our best and we'll come back to you as soon as it's ready. It lets users know to not keep clicking the button and opening up 10 different copies of it. As the main objective of our splash screen is to just stand as a waiting place while our engine is loading up, one of the other main objectives is to make sure that the splash screen doesn't take up any major overheads, so we need to make sure that the splash screen is done in the most simple way possible. Let's just add these classes in, or these functions in here. There we go. For our actual splash screen itself, we will need a class just to know what is going on with this window. So instead of calling this splash screen, I'm going to call this very specifically splash window. I've just created this for us. It's just named splash window. We've got our basic constructors and deconstructors. Let's just add those in. And we've got a W character variable here. This is so that we can store what type of output debug message we want to show to the user. So for example, right now we're loading up the simulation, or right now we're scanning through the database. We can all put this information directly in this variable. We have created a class for our splash window, but we still have yet to actually create our window class itself. So we need to now be able to inherit this off of, let's say, a Win32, and we should have this one as window. Whenever we are inheriting, we just need to make sure that that is set to public. We should then just be able to come in here and click include and add our platform Win32. Let's just go back here, Win32. And then we can add our window class. The only problem for this is that we don't actually have this built yet. So let's go up to our folder view. Let's come back in here and let's drop down to platform. Let's come back into Win32 and let's create ourselves two new files. Let's create ourselves a window.h and a window.cpp. Now we should already be able to see this should be correctly drawing in, or this at least should be successful. We are going to need a SubObject class, a class to inherit all of the different features of all of our different windows from, and it's not just going to be on our window class. As I said, buttons will also count as windows. So instead of coming back to this in a moment, I'm just going to add in our SubObject class as well. That's SubObject.h and SubObject.cpp. Let's come back and let's just add those to our solution. So let's come down to, we're back to our folder view, one moment. Come down to our platform, Win32, and we can add this in. So both of our new items are going to be classes. So let's just come here, and let's just add these in. As I say, these are all going to be classes, so we can just keep them in here. Put that in private, and we are all set up. For our SubObject and our window, I've gone ahead and created us a couple of files just to get us started. So this should work for our SubObject. Let's just make sure we put the pragma once in there, and let's just make sure we put the dependencies in here as well. Let's put our Olympus, and let's put our SubObject class, and then we can come and turn to our window. So let's have a look in here. Let's bring this class into our .h file. Again, we're going to need our pragma once, and because we are inheriting this off of our SubObject class, we're also going to need to include that. So let's just include our SubObject class. That will correctly load that in as such. Let's just add our dependencies in here as well. We can start to move on. Now our window class and our SubObject class are already things that we have built similar things for before, and that is in regards to our win entry that we put in the very first episode. So if we come back up to our blank project and we come into our win main, we can see that we've got quite a lot going on here that we will now need to copy into this type of file. So let's have a look. If we come back up to our win main, we can see the overall methodology that we used in the first episode to create our window. We're going to need to do very similar now. So let's come up here and let's see what we need to do. Let's come to our initialize variables. Where's that? Come up to here, go to definitions, and we'll see this in here. So we need to initialize all of these items. Where did we store? So if we just grab all of these items, we can actually just bring these over and put them into our SubObject. Put these as private, and let's just bring these in as such. These are not correctly named for being put inside a class, so we're just going to put a little m before all of these, just to say that these are class items. Our subobject is just going to be a subobject. It's not actually going to be any form of window specifically. So window height and window width don't really apply here. For this reason, I'm just going to come in and I'm going to actually put that one directly inside our window class. Let's put the M's on here as well. Save all of that off, and let's just create our subobject class. Let's create this constructor and the deconstructors. Here we go. It's not giving us our namespace as we like to use it, so let's just add that in correctly. Delete those, and we're away. Perfect. Now that we've got that created, let's come back to our subobject item. First of all, this is a W character array and we're not actually in a window, so let's just get rid of that. Now we can use W character arrays for this, but it's actually a lot easier to assign these very quickly if we just put them in strings. So let's just change this quickly to a standard W string. Put that in there like such, and remove the array because a character array is basically a string. Now that we've done that, we've got two new variables to use, and we need a way to initialize this. So we can just run these in our constructor to say that anytime we use one of these subobjects, we're going to need to name what class we're using and the title of that subobject. If we then come over to here, what we can then do is we can just actually call this in our constructor. So let's just call this in our constructor. Paste that in for us in there. And obviously we haven't put the same type of variable for input in our CPP file as we have in our .h file. We're also going to need a way to be able to initialize our H icon. So let's just add that one in as well. And let's just say H icon, and in our subobject here, we can just say m_H icon is equal to icon. Again, we're going to need to add that in here. There we go. With that added in here, it means anytime we create a subobject, we're going to need to define these three variables. And these are the three variables in here. So that should correctly fill out our class. Now we've done that, we can start moving on to our window.h file. And this is just going to need for primarily the same details as our subobject. You can just bring this in here and just copy and paste this in as such. Now we haven't actually added these yet, so let's just add these in now. Again, we're going to have the same problem as we had with our subobject, that it hasn't put it in our namespace for us, so let's just do that. Let's just grab this here and put this in here like so, and remove this Win32. Again, we just do this just to make it all a little bit easier to read. Now, this is giving us a lot of problems here because we are not feeding in this information back into our subobject. So if we just come in here and we can say Win32 SubObject, and we just need these variables to be fed back in here. Let's just do this. And all I'm going to do for this is I'm just going to pass along here and just remove all of these items. If we do that now, it means we're passing these straight from our constructor of our window straight into the constructor of our subobject. So that should be fine. We do actually have two variables in our window, however, so we're going to need a way to actually construct those as well. I'm just going to remove this window item here as well, because M width and M height should do us good enough. To feed that in, I'm going to just add some extra constructors in here, and I'm going to say int height. We should always start with the width, so int width and int height. And then we can just copy these across to our window, and we can construct these exactly the same. So m underscore width is going to be our width variable, and our m underscore height is going to be our height variable. That means everything here inside our window and our subobject class should now be able to be initialized from our window constructor. And this is exactly what we had in our Win main. We've got these 5 variables, and we called out initialize variables to actually initialize these items. That means the only thing that we need to do is then call that inside our splash screen class itself. So when our splash screen is being created, we're going to need to inherit the different items of window. So let's come in here and let's come to splash screen. If we come down to here, we can see that we've got our red little error message here, and that's because we're not feeding in the correct information. So if we just come in here, we can just throw this line in, and this should give us all of the information that we need. So we're calling our class splash screen and our title splash screen. We're not feeding in an icon currently. We want our window to be 600 width and 500 height. I think this is the wrong way round. This should be 500 height and 500 width and 500 height. Now we've done that. That is absolutely fine. It's saying our m underscore output message is actually not being constructed so a moment. So we can just go in and we can just construct that with a WCS copy message. Let's say our m output message, and let's just say splash screen starting. There we go, and that should put us in good stead. Let's go back to our Win main and let's have a look at see what else we needed to do. So if we're going through our Win main, we can start to get rid of some of these things because we now no longer need to use them. Let's get rid of this and let's get rid of this just so that we know what's going on. The next thing we'd done before was to create a window class, and we actually have a function for this already. This is going to need to go into our subobject because every single one of our subobject classes is going to need to be able to register a new class. Our function name here is a little bit obscure, so I want to rename this to something that's slightly more appropriate for subobjects. What I'm going to choose here is register new class because I think that's a little bit more fitting for registering a new class for our subobject. Down here we're going to see that we have actually need to change some of these for our variables that we've already got built in. So this is going to change to our m underscore h icon class. This is going to change to our m underscore icon class, and this is going to change to our m underscore class. We're going to come back to the Windows process in a moment. We will need to just make sure that we've got our namespace for our sub-object, and that should solve all of the problems apart from our Windows process. So let's just do this in here. We'll put register new class, and I do want to make sure that this is a virtual function. That means if we want to overwrite this later, we can indeed do so. Our m underscore class is actually suddenly set to a string, so we're just going to need to call that in its W character format. Now that that's done, we have everything that we need to set and register our class in the first place. As I say, we'll come back to this part in a moment. Let's come back to our Win main. We've just added this in, so again, let's go back and follow the same pattern and just delete this from our Win main. I'm trying to get rid of this so that we no longer need it. The next thing we need to do is initialize our window. So let's grab our initialize window down here and let's put back to our SubObject. Now I'm sure you can imagine initializing a window is not actually something a SubObject will do. So we want to put that inside our window. But every single time that we create any SubObject, we are going to want an initialize function. So let's just put a virtual void initialize in here. Let's just spell initialize correctly. I want to make sure that all of our SubObjects have an initialize, but I don't want to actually create it inside this function. So I'm just going to zero that off, and that will just mean that we only have to create that in our follow-up functions. Let's come here and let's just copy and paste our initialize function to our window. And instead of the equals 0, we can just change that to override. That means this is where we're actually declaring this function. Now we've got this window initialize, we can come back to our win main and we can copy everything from in here. This is good, but it's given us a few errors. Let's have a look to see what this is. So m_window class is not being recognized. So let's just put this in here. And this is a string, so we're going to need to make sure we're giving it the W character version. It's now saying m_class is inaccessible. The reason for that is I've changed all of our variables here to be private, and that means they can't be accessed by our inherited classes. To change that, we can change private to protected. It's very similar to private, it just means you get extra functionality, and one of those is the ability to be able to call this in. So that is now gone, that error has now gone away, and it's given us the same error for our window title. If we just upgrade this for an m_title and just change that into a character string. Go look, our window width needs to change to m_width, and our window height needs to change to m_height. Now we've done that, all of our errors have gone away, so we've now got the first two steps for creating our window. Let's go back to our win main and let's get rid of our initialize window. Initialize window and initialize window. Let's have a look to see what else we've got in here. So all of these icons are all these variables are no longer going to be needed, so we can delete those as well. Our message loop is already going to be declared in our other entry function, so we can get rid of our message loop as well. Let's get rid of all of this and let's just leave our window process. Let's put our window process in our SubObject. I have just accidentally got rid of my copy there, so let's place this in here and let's SubObject this. Make sure that this is in our namespace. Let's make sure that this is created as such. Now if we do this, we can see here that we're getting an error here. And that's because you cannot actually just run this function straight from a namespaced class. If we were to not namespace this function, it would mean we could only create one of them. And we want to be able to change this function depending on what SubObject we've created. So we're going to have to work a little bit of Win32 magic here to be able to point our program to say this is the exact process that we want to use. To do this, I'm going to add us in a couple of extra functions. Now, these functions can become quite complicated, so instead of explaining all of them, I'm just going to say to you, This is the best way to do it. You can find the code on the GitHub, and it's best to just copy this across, although I will explain what each of them do. Let's come up to our CPP file, and I just want to be able to add these new functions in. Again, I'm going to just copy and paste all of these functions in, and then I'm going to explain what they do afterwards. This function here I've set as an equals 0. So this function here is set specifically for our window class or any inherited classes that we make. That leaves us with 3 overall functions. I've tried to give them as much of an obvious names as possible. This function is going to set up all of our message handling. This function returns a pointer specifically to our message handler class, or the function that is namespaced to this class. We've then got 2 different functions here, and these are going to operate the same as our window process. So we've basically got 2 Windows processes here. This one is for our inherited class, and this one is for our subobject itself. This means that we can put things in here that we want every subobject item to be able to carry, and things in here that we only want that specific class to be able to carry. Now that I've explained roughly what they do, let me show you how these work. We have our setup message handler here. So what we can do is, instead of window process, we can just paste in setup message handler. When this is ran, this says that we want to create a new process. This process is going to continue and loop until the non-client create message is sent. When the non-client create message is sent, we are going to create a new variable of subobject, which is going to point to the subject we need, and we are going to static cast it. We are then going to run a couple of extra fun codes on it, and we are going to static cast it to this here. This is the pointer to our function. So all of this function here does is run some extra fancy code to put us in this and this functioned or namespaced function. Again, our common message handler will just be there so that we can add in global messages, global things. So if we want to set a maximum size of the window, for example, we can do this in here so that we don't actually have to do it in Windows, etc., etc. We're no longer going to use our window process, so we can now get rid of this. This is all set here. This is all set here. And you can now see that this function here is working absolutely fine. Now that we've done this, what we're going to need to do is we're going to need to take this message handler function and we're going to need to put it inside our splash screen window, because now every subobject we make is going to need to have these items. So let's come back into here and let's put this in here. Again, we're going to need to change this to override. Let's just create this function. And all we're going to do for this at the moment is we're just going to return our common message handler. We're going to give it the same exact details as above. wparam and lparam. So let's have a look at how that is working again one more time. When we go through, we set up our message handler, which pulls in our assigned message handler, which pulls in our message handler. Now this message handler here is the one we're now creating in our splash screen. So if we come down to here, this now pulls this message handler. Normally this type of function would return the default Windows message handler. So if we come to our common, what we're going to do is we're going to return our common message handler. So if we come back to SubObject, we can look at our common message handler, and in here we're going to be returning our default Windows process. It just means we get 2 levels of customization on this. To actually make this work, we're going to need to call the functions that we've just created. So we're going to need to call register new class. Let's just do this correctly and say Win32 window register new class. Let's say Win32 window and initialize. That means as soon as the splash screen is created, it's going to register the class and initialize and open the window for us. We created earlier 3 different functions in our namespace for our splash screen. Let's go back to them now and let's have a look at how these can work. First of all, this is not set up with our normal namespaces and it's got our Olympus API. So let's clean this up slightly. Let's go namespace, splash screen. Let's just copy and paste these in. We can then get rid of all of this, and all of this. What I want to do is I want to just create one version of our splash screen. Now I'm not going to make this a global variable because I only want this namespace to be able to access it. And what we're going to do is when this says open, we're just going to throw and create this variable. So we're going to check to see if it's already set to null pointer. If it is set to a null pointer, we're going to return, or if it's not set to a null pointer, we're going to return. So if it has already been created, we're going to return. And then if it hasn't already been created, we're going to create a new window, which will obviously display as a window. Now we can test this now, but let's just come back to our WinMain class quickly because we're really not using this at all now. So let's go in and delete this. Now just stop that class from giving us any errors. We can now open a splash screen and that should work absolutely fine. So let's have a look to see what that looks like. If we come all the way back to our splash screen, not splash screen, if we come all the way, let's go to our win entry function and do it from there. So if we come to platform, we can come to public and we can come to win entry. Let's include our splash screen in here. So that is going to be engine and that is going to be splash screen. Just before everything is initialized, let's go ahead and create our splash screen. So what we can do is we can just say splash screen open. And let's test that out. Now we're getting an error message here and I know actually why this is. For this to work correctly, we actually need to feed one extra piece of information into our system. So let's come up to our window class up here and let's come up to our initialize. What we actually need to feed in is the class itself, and where we need to feed that in is actually at the very end line here. We're currently saying null pointer, and this is the variable that we need. Now to be able to use this window class instead of the SubObject class, we need to feed in this class into that algorithm. So we can just put void and this at the end. Let's try and run this again now and see how far we get. Now we've done that, we can see we've now successfully once again got a window on the screen. We have finally now got a working splash screen, and we are going to keep this one. But this is not exactly the splash screen that we probably had in mind. For the start, it just looks like a white box, and it's not very nice. And one of our main objectives is to make sure that everything looks as nice as possible. So let's have a look to see how we can work on just making this a little bit nicer just to start with. Let's come to our SubObject here, and let's come over to our registered new class. We can actually set a better background color for this, and one of my favorite UI looks that I really try to replicate in all of my programs is literally right in front of us. I really like the Visual Studio UI, and this should give us the rough same color that this has. So let's have a look at this now. There we go, that's giving us a much better area to work with. But again, we're on a splash screen, and generally a splash screen won't have all of this details at the top, so we need to find a way to be able to get rid of that. Let's come down to here, and let's come back to our window.cpp, and let's have a look at how we're doing this. Currently we're using a WS overlapped window. Currently that gives us all of the features here, including put the borders in, etc, etc, but we don't really want that. So what we can do is we can change this to pop-up. We can actually change this to pop-up window. If we run this again now, we can see that everything is coming, but we don't have an amazing amount of control over where this goes. I'll fix that in a moment, but one thing I just want to change quickly is I just want to come back into our SubObject.h, and I want to add us a new variable in. This is going to be a return of our handle for our window. It's a HWND, and I've just already put as a little get function for this variable. Let's just move this across slightly. Come back up to our window H, what I actually want to do is just make sure we're using now our m_handle class, and this just means we're keeping a copy of it for when we need it. Let's just throw that in there as such, throw that one in there as such, and throw that one in there as such. Now, as I said a moment ago, if we throw this in and just play this, we will find that the window appears in the top left hand corner of the screen, and this isn't really what we want. So I have got a little bit of code here that is just going to find the center of the screen and place this window in the center of the screen. Let's just do this as such, and replace all of this with this new code. As soon as the new code works, here we go. This is basically exactly the same functions as we've already created, apart from we're going to find the area of the desktop, the area of the window itself, and we're going to use these details to find the very center of the screen. So let's just run this again now, and we can see that this is in the center of the screen. Excellent. What we now want to do is we want to try and make our splash screen look a little better. We had already put in the beginning this m_output message function. So to be able to use that, we're going to need to fill out our message handler class. I have created this to get us started. This basically says that we are going to run a switch case on this message. When we get the call that we need to paint our window, we're going to take in all of the normal things that we need to paint our window. We're going to run a few checks on our window. So we're going to set the background mode to transparent. We're going to set text color to white. and we're going to set text alignment to center, and then we're going to write out on our screen our m_output message. We've already set that to splash screen starting. Now I'm getting us an error on m_width, so let's come and have a look to see why that is. If we come back up to splash screen, we've got public Win32 window, and if we come up to window, let's have a look. I expect this is probably set to private. There it is, and that's again the reason we can't access that. So let's just change that to protected. And back to our splash screen now, we can see that this is now working. So let's come in here and let's just run that. There we go. We can now see we're printing text to the bottom of the screen. Now this is useful, but we are going to want a way to be able to update that. So the best way to do that is if we just create a new function up here. What we're going to want to do here is we're going to want to declare a new type of message to be listened to, and this is just going to be called the output message. So we're just going to define this above our splash screen. This is going to be a WM user message, which is basically the user custom message for us to create. And I'm just going to add an extra 1 on top of that just to create a new one. This is WM output message. And what we can say is if we come down to here, we can add a new check for our output message. So let's just add a new check in here. What this says now is whenever we get this message, we are going to create whatever is in our W param here. We're going to turn that into a W character message. We're going to copy that into our m_output message, and then we're going to redraw our window. Now, that sounds good, but how do we send and create this? Now, if you remember earlier, we created this add message function. And this is set in our namespace, so specifically so that we can pretty much call it from anywhere. And if we just add this line of code into this add message function, then we'll be able to send a message. Now, if we press play at the moment and we add this in, we can see that we're seeing splash screen started. But if we come back into our win entry function, and we come to our splash screen, we can now update this text. So we can say splash screen, add message, and we can say starting engine, or let's say starting application in this case. If we run this again, let's just make sure we're rebuilding this solution just to make sure that this is working correctly. Now that has loaded back up again. Let's just try and run that again. Now that's still coming out twice. Let's have a look to see and figure out why that is. So that one's add message. Come down to our splash screen. Let's see if we can figure out why that is. So we are using our new global variable to pull that in. So that should be absolutely fine. And this appears to be fine. I'm going to go and have a look to see if I can figure out why this is. I have been looking into this, and the simple reason that this is not working is because we are not actually running our message handler yet. So we will look into another way to do that in a moment, but the application will still work, and that will work in a moment. So let's have a look what else we need to do in here. So let's come back up to our splash screen. One of the things that we would like to do at this moment is just identify what type of engine mode we are loading up in. And to make that a little bit easier for us, I have just got this. Now let's come down to our text line and let's paste this code into the top of it. This is going to say that if our engine mode is not in release mode, and that's the only one that we don't actually want to print out this extra piece of string, then we're going to get to our engine mode and we're going to add the word mode on the end of it. So if this is debug, it's going to say debug mode. If it's in editor mode, it's going to say editor mode. We're going to set the text alignment to the very right, and we are going to put this just in the top right hand corner. Let's try run this now and see what it looks like. This is not actually doing this, and I expect this is because we just need to rebuild this solution. And let's try that again now. We can now see that we are successfully loading in editor mode. So this is starting to look much more like the splash screen we were expecting at the beginning of the game. However, we would expect some form of graphic on here. And before we leave today, I'd like to show us a way that we can add a basic splash screen image to this window. I'm going to start by just closing this down, and I want to add in a new class into our application. Let's come up to folder view. Let's come to episode 5, Olympus, source, platform, Win32. And then I'm just going to add as a new class in. I'm going to call this Win32 utils.h. This is so that we can just add in a couple of extra functions in here that can be just used in general. One of these is going to be that we want to be able to draw a bitmap file. Let's click include and let's just put our Olympus. No, let's not put Olympus in here. No, I disagree. Let's put Olympus in here. And then let's put a namespace of Win32. I'm going to add another namespace in here just called utils, and we're going to add this function. This is going to be add bitmap. We're going to do it by file name, so we're going to have to provide a URL. We need to feed in the actual HDC of the window, and we need to know exactly where to put that. I've just put that as an =0 just to say if we don't give it a number to actually load in, it's going to automatically default as 0. We're going to also need to add in the other window file here, so let's just Win32 utils.cpp, and let's just add those into the solution. So let's come back to our solutions view, come down to our Win32. There's no classes here, this is only a namespace, so we're going to put this in our public. Let's go to our platform, Win32, and just add in our Win32 utils files. Add that one into private. We are going to need both of these in here. I thought a moment ago that I was only going to be creating the .h file for this, but I am going to be creating the .cpp file as well, so we can get rid of .olympus from in here and put pragma once instead. And then once that is done, we can import our new function. What we can then do is come to our .cpp file, and we can just paste in this function. Now, I'm not going to go through how or why this function works, but all I'm going to tell you is it does add a bitmap to the window. It doesn't give us a lot of functions in regards to what image files we can put in there. It's just going to be a bitmap, but that's fine for our splash screen because we don't really need to load up anything really heavy anyway. To be able to call our new function, we're going to need to include our Win32 header. So let's just include platform Win32, and then that's Win32 utils, and we can just call that up here as such. This is just Win32 utils and add bitmap. We'll call in our HDC, and we just want to put that as 00. As said before, we don't actually need to put these variables in because we put the =0 in the header file. We now need to find a URL to set and an image to be loaded in. In our Olympus Mons folder, I've actually added us an image to work from. So if you go into our Olympus folder, I've added us a content folder, an images folder, and inside here I've got a new image to use for our splash screen. So let's have a look and let's see if we can take this entire URL. Let's come back into here and let's just paste this into here. So it needs to be an L format, And we need to do this as such. They need to be backspaces as doubles, double, 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 and double. And then we need to type in splash. Let's have a look to see what we just named that. That is Olympus splash.bitmap. Two of those. That should be Olympus splash.bmp. Now, we actually share the same solution directory, so we can actually just go ... back Olympus content images. And if we run this again now, we should see that our splash screen now has just a little bit more magic. Now that is great, and I hope you agree that this is looking a lot better. But there's a few things extra just before I'd like to do before we leave today, and let's do this as such. Let's close this down, and I want to come back to our simulation class that we created earlier. I want to create a new class in here, and I want to call this one pre-initialization, or pre-initialize will do absolutely fine. Let's just create that in here. If we come back to our Win32 function, we can then come in here and we can just say that we want to run our pre-initialization before we actually go any further. Now, to be able to do that, we're going to need to make it a subclassed item. So we need to put it in our application. Let's put this in here, and let's just copy this, put this above initialize, and let's just call this pre-initialize. As this is virtual in this function, we're then going to have to come up to our simulation, and we're just going to need to make this virtual and override. Then let's come up to our Win32 function again. Now, why have we done this? Currently, this initialize function here goes directly to our blank project, but we may need to be able to initialize certain things in our engine files directly first. So that's why we're actually using a pre-initialize function. I actually want to put our splash screen open in our pre-initialize function, so let's just do that now. Let's add our splash screen in here. In fact, we've got it in our Win32 already, so let's just copy and paste it out of there. And we now have our splash screen open. A couple of extra little things that I want to do. Let's come back up to our blank project and let's have a look at our application currently. The only things we're really doing in here at the moment is setting up our per game settings, which we're not really going to change, and using this here. Now, this is not something that we specifically need to call inside our game, so I want to just take this and I'm going to put this over in our simulation class in our pre-initialize. That just means that we're going to be able to successfully now clean up this application. And just the same as we have done here, our PCH files are actually our Olympus.h. So I want to come up here and I want to have a quick think about how we're organizing these files. Let's come up to here and I want to add, let's come up to our folder view, and this time instead of working in Olympus, I want to come to blank project. Let's come to our source, and we currently have 4 files in here. I want to add 2 new files in here just to clean this up a bit, and we're going to call this blank project.h and we're going to call this blank project.cpp. And what we're going to do is we're going to combine all of these files into just these 2 files. Let's come back to our solution view. If we come up to our blank project, come to properties, and then come to C++ and precompiled headers, we can change PCH up to blank project. Click OK, and that means that instead of this being our PCH file, our new PCH file is actually called blank project. Let's just import those in quickly. Add that in as such. Now what I want to do is I want to go into our application.h class, and I want to take this from here and I want to put it into our blank project.cpp. Now I know normally we would not put a class in a CPP file, but this is a good way to do it because we can put everything in just one file, and then by doing that we can actually make it so that everything is compact into here as this one file to get everything going, and then we can build everything game wise outside of this. So I've done this here, I've brought this into here as such, and if we come to our application.cpp, what we can do is then we can just come in here, copy this all across, and just put this under this declaration. Just need to go back to there because I accidentally didn't do that one correctly. We can put this back in here as such. So we now have our class creation or declaration here, and we have our functions down here. We've even got our application here. Now that we've done that, we don't actually need any of these files so that we can now remove them. Let's get into some good form and let's put these back up into the correct places. We can then also just change the name application to something a bit more fitting like blank project. So let's just go through here and let's change all of this to blank project. In fact, let's just copy this, change this to current document, and just change application to blank project. There we go. Now we've done that. That all seems to be drawing in correctly. And we have managed to put that all down into two simple files. We can press play. We are getting an error here. This is because our blank project.h file is... Now we are calling in our blank project file. Let's have a look to see why that is. This is actually a really quick and simple one to fix, and this is just because we did not import our win entry function. So let's add that include in there, and let's just try running that one more time. And we can see that everything is running up nicely. Now, one of the main reasons I wanted to do this, because this is just our blank project. This is not anything like a full game. So I want to keep this as cleaned out as possible. To show that we're going to do this even further, let's just make sure that we minimize all of this down and clean it up slightly, as we're not actually using any of these functions. Do that from here. Do that from here. Do that for here, and do that for here. To make this even less, we can actually delete these and delete these and bring these up here. This will just clean up everything apart from our per game settings, and it just goes to show the proof that we can load all of this up with very little code from our actual game itself. Everything is in here, and we can just run that absolutely fine. This picture that I am supplying here is a great picture to get us started, but when we're actually loading up a full game, we're going to want the option to be able to actually choose which game or which picture we load up on our splash screen. So what we're going to need to do is we're going to need to say, if there is no supplied picture, we're going to load up this picture. If there is, however, a supplied picture, we won't load up this picture. So the next thing we need to do is we just need to find a way to keep track of this. And I'm going to do that as a per game setting. Let's come over to our Olympus. Let's get rid of our engine and our PCH for now, and let's come back into our core. Let's come into classes and let's open up our per game settings. Now I'm just going to make this a W character array, exactly the same as everything else, and I'm just going to call this splash URL. I am also going to get two of these getters and setters and just set these exactly the same. So let's just take this here, splash URL, and this should be splash URL, and this should be splash URL, splash URL. Now for this one, I don't want to give it this functionality. So what we're going to do is we are going to call in a constant W character, and we're going to call this one URL. And then we are just going to WCS underscore copy, WCS copy underscore S, and we're just going to say M underscore splash URL, and then we're going to say URL, and that just means if we want to call that, we can change the URL. Now I have decided that we are going to do this in a different way. So what we're going to do is we're actually going to set our splash screen URL by a resource that we can set, just like we have with the other items here. So let's have a look here, and let's just post that in. And what we're going to just say is we're going to say load string. So let's come back to our blank project, and we can come back to our resources file. Now let's close resources in here, and let's just see if we can open this back up and come to our string table. Now our string table, we can just say IDS splash URL. In this case, we're going to want to create a basic settings the same as we had before. So this is going to be content, and then images, and then well, we're going to need to create a new function. So let's go and have a look into doing that now. If we come back into our Olympus folder and come back to Olympus, come back to blank project, come to our content, we can add a new folder in here. And we just call this images. We can then paste this file. One moment, I've done this wrong. Let's take that out of there and let's paste this into here. If we then come into project images, I've now got us a new file to work from. So now I've got that, I can figure out what this is called. This is blank project splash. That's blank project splash. Just like we have done before, and just remember we do not need the quotation marks in here. Now if we save all of this off, we should then be able to use this to draw in a different splash screen image. I have just realized that we need the .bmp on there, so let's just put that in there like such. If we then come up to our blank project and blank project.cpp, we can then use this as another example of how to actually bring in this item in. So let's just put this in here, and this is splash URL. Now it's seeming like we can't pull this one in immediately. Let's have a look to make sure we are correctly drawing that in. IDS splash URL, and let's just load up our resources. Let's save all of that down, splash URL, and if we come back to our blank project now, everything is now working correctly. So we can do that as such. If we then come back up to our splash screen, we can come out of here, and we can say that we want to actually use per game settings, and then we can get the splash screen URL. If we now hit play, we can now see that the image has now changed. So what we can actually do now, if we come back to per game settings, and what we want to do is close this, come back to our per game settings.cpp. We just want to make sure that that is being set correctly. We want this one to be our M underscore splash, URL, and we want this one to be set directly to the ..// content. No, this one should be Olympus content images, and then let's just have a look to see exactly what that one is called again. It should be Olympus Splash, but I just want to make sure for definite. Content images Olympus Splash. BMP. The reason I've done this now is if we come up to our blank project and I just blank this out slightly and we run this again, we'll notice that we're pulling up the splash screen for our engine specifically. If I now then add in a new URL using this, we can now pull up the splash screen that we've supplied to the game. This has been the longest episode that we've done so far, and with everything just added, this will give us a running start to start moving forward with our engine and our future projects. In the next episode, we're going to be looking more into creating a Win32 UI. We'll also be customizing a basic window so that we can place our simulation into it, and this will stand as a basis for when we start to build up our editor. We'll also be building up an event handler class so that we can respond to key events whilst our engine or our program are running. In between this episode and the next, there's going to be an extra video that will talk about the reasons that we are building our engine in this manner, and also where we'd like to see this in the future. So if you're curious to the answers to any of these questions, make sure to check that out. That being said, that is everything for this tutorial, so I will see you next time where we'll be creating the DirectX ready game engine.